It started with a bacon roll and a microwave oven. And now it's poised to transform the recycling of a packaging material whose only fate was landfill. Technology developed in Cambridge and now commercialized by Enval has resulted in a process that can turn toothpaste tubes and drinks pouches into both aluminium and fuel in just 3 minutes. The bacon roll, as the story goes, was microwaved for so long it turned into a charred mass of carbon that began to glow red hot. What was happening was an intense heating process called microwave-induced pyrolysis.
I'd heard about the over-microwave bacon roll from an acquaintance at Cambridge, and I was intrigued by the possibilities. And I was wondering whether the pyrolytic process could be used to recover value materials from packaging wastes. We had one particular type of packaging in mind, the type of plastic-aluminium packaging that's commonly used for drinks pouches and cartons, toothpaste tubes and pet food pouches.
Plastic-aluminium laminates are widely used because they actually tick a lot of boxes in the sustainability list. They are very light, they are very good for transport as a consequence, they have very few resources embedded in the material. However, the last box, the recyclable box, was so far unticked. And this is what the Enval technology allows. The Enval technology allows these materials to become recyclable and therefore tick that last box that brands were looking to tick. Before we developed the Enval technology, most of the plastic aluminum laminate used in packaging ended up in landfill, or in the best case scenario in energy from waste. But the important bit is that the aluminum was not recovered.
From our small-scale laboratory experiments, we knew that the technology offered a genuine recycling route for this type of packaging. But the waste industry can be slow to take on new technology. The margins in environmental services are small, and we needed a working full-scale plant to convince our potential customers that the process was viable.
Why building a commercial plant? Well, in the waste sector, it's like the chicken and the egg. No one is going to develop a technology to recycle certain materials if those materials are not collected and segregated. At the same time, no one is going to collect and segregate if there's no technology to treat them. We actually managed to break that pattern. We got the investment, we now have a commercial plant that we can show, demonstrate to the waste handling sector, and at the same time, we can start telling the waste handlers that they have to start collecting and segregating these materials because it makes commercial sense. The technology is there and they can be recycled and we can avoid them from going to landfill.
Like the original experiment, they take carbon in the form of granular particles, add the laminated packaging, replace the air inside the oven with nitrogen, and then microwave at 600 degrees Celsius. The laminated material separates into clean aluminium flakes and hydrocarbon gases and oil, both of which are collected and used to power the plant.
Enval was born as a technology development company. We were not in the beginning thinking actually becoming an operator of our own process. However, we needed to demonstrate that the process worked, and therefore we built our first commercial plant, and now we operate it on a commercial basis. Essentially, the plant has a payback time of 3.5 years, and therefore, if we can generate money from it, why not? Over the years, we have continued our relationship with the Department of Chemical Engineering in the University of Cambridge, essentially because we can have collaborative projects that can end up in new processes being developed for new materials that do not have a recycling process.
The researchers are continuing to look for new opportunities to recycle valuable materials and reduce the need to send waste to landfill.
We've demonstrated that a lot of troublesome waste materials can be pyrolyzed using our microwave technology, but it's not always economically sensible to do so. The challenge now is to identify which processes are likely to be commercially viable and which of those will attract the necessary investment funding needed to bring them into commercial reality. One example is the use of the processes for pyrolyzing used car tyres. We've shown that this is viable on the laboratory scale, but again we would need significant commercial investment to bring it into commercial fruition.
Companies like Enval that develop technology and environmental processes to recycle materials are very important and will have a very important role in the future in order to ensure that the circular economy works and that we care about the materials that we're using for the sake of the environment.